Hello and welcome to this channel. Good morning, good afternoon, good evening, wherever you are in the world. This is Samuel and Akon. Welcome you to this channel, welcome you to this lesson, welcome you to this video. So, this is our series on density. We'll be looking at relative density today. We've been looking at density so far. We've had 3 classes on density. So, this is our 4th lesson. We'll be looking at relative density. What is relative density? Relative density, actually, when you say relative, when you hear the word relative, that means it is compared with something. Density is compared with density of something else. So what is the base of comparison? When we're looking at relative density, we are trying to compare the density of various substances with the density of water. How do they compare with the density of water? Water is one of the most common substances in the world. So we are trying to compare the density of other substances. How they compare with water? Are they smaller? Are they larger? How many times larger when compared with water, or how many times smaller? So, relative density of a substance is defined as the density of the substance compared to the density of water. Relative density of a substance can be defined as the density of a substance compared to the density of water. So we have density in, we're going to write the formula now. RD stands for relative density is equals to density of a substance compared with the density of water. Okay. Density of a substance compared with the density of water. Okay? So there are other formulas that can actually also be used to calculate density, relative density. Another one is the mass of a substance over the mass of an equal volume of water. Mass of a substance over the mass of an equal volume of water. When you take a volume of a substance and take the volume of water and you measure the mass of that substance over the mass of that water, you can also calculate the density. Another one is the weight of a substance over the weight of an equal volume of water. The weight of a substance over the weight of an equal volume of water. That is another formula. So another one is the upthrust in a liquid over the upthrust in water. The upthrust in a liquid over the upthrust in water. This is still another formula to use to calculate relative density of a substance. The upthrust of that substance produced in a liquid and the upthrust produced in water. These are various formulas. I have density of a substance over density of water, mass of a substance over mass of an equal volume of water. Then I did write that one down. Weight of a substance over weight of an equal volume of water. The upthrust in liquid, upthrust in water. These are various formulas for measuring density of the relative density of a substance. So right now we're going to calculate the relative density of gold, silver, mercury, and aluminium. So given that the density of gold is this, density of silver is this, density of mercury is this, density of aluminum is this. So for the relative density of gold, this is density of substance over density of water. Density of gold is 19,300 kilogram per cubic meters. Why that of water is 1000 kilogram per cubic meters. This will cancel this. 0 cancel 0. 19.3 divided by 10 is 193 divided by 10 is 19.3. So the relative density of gold is 19.3. So for silver, we have that the relative density of silver is equals to, density of silver is 10,500 kilogram per cubic meter. That of water is still 1000 kilogram per cubic meters. 0 cancels 0. The 2 0 cancels 0. 105 divided by 10 gives us 10.5. So we have for silver, the answer is 10.5. You can go ahead and use the same approach and get the relative density of mercury. For mercury, you're going to get 13.5. This is the relative density of mercury. Then for aluminium, you're going to get 2.71 when you solve. So you discover that relative density doesn't have units. Relative density doesn't have units. It is unitless. It has no units. It has no units. Okay. So relative density has no units. It is unitless because it compares density of different substances. It is actually unitless. Okay. It is actually a ratio of density, so it is unitless. So right now we want to look at density in kilogram per cubic meters and density in gram per cubic centimeters and the relative density. We're going to look at gold and silver. The density of gold is 19,300 kilogram per cubic meters. The density of gold is 19.3 gram per cubic centimeters. The relative density of gold is 19.3. For silver, the density is 10,500 kilogram per cubic meters. 10.5 gram per cubic centimeters. The relative density of silver is 10.5. So looking at this value, if you try to compare, you will discover that the density, when you divide the density in kilogram per cubic meter by 1,000, it's going to land you on the density in gram per cm cube. And when you remove the units for the density in gram per cm cube, it lands you on the relative density. So invariably, if you know the relative density of a substance, you can as well, that automatically enables you to have a knowledge of the density of that substance in kilogram per meter cube and in gram per meter cube. If the relative density, like gold now, is 90.3, then the density in gram per cm cube is just to attach the unit directly. Okay, so let's assume now we have a substance. The density is 2.5. The relative density is 2.5. Then the density of this substance in gram per cm cube will be 2.5 gram per cm cube. The density in kilogram per meter cube is going to be 2.5 times 1,000. That will be 2,500 kilogram per meter cube. So invariably, once you know the density, you know the relative density of a substance, that means you know the density of that substance, both in kilogram per meter cube and in gram per meter cube. And also, if you know the density, you know the relative density as well. So next, we'll be taking a calculation. We'll take a calculation on relative density before we proceed. So we have a question here. An empty 60 liters petrol tank has a mass of 10 kilogram. Its mass when full of fuel of relative density 0.72 is this. So this is our tank. It's empty. Our tank is empty. The mass of empty tank without content is 10 kilogram. So what will be its mass when it's full of fuel of relative density 0.2? So all we need is to calculate the mass of the fuel. We just need to calculate mass of fuel. Mass of fuel is what we need to calculate. Let's call that M sub F. So we know the relative density of the fuel. Relative density of fuel is 0.72. So that means the density of fuel is 0.72 gram per cubic centimeter, or 0.70 times 1000, which will give us 720 kilogram per cubic meters. This is the density of fuel. So before we can calculate the mass of fuel, we need to know the volume and the density. From the formula, density is equals to mass over volume. For us to calculate the mass of fuel, we need to know the density of the fuel and the volume of the fuel. The density of the fuel was given indirectly in form of the relative density. So we know the density right now. So the next thing we need is the volume of fuel. So how do we get the volume of the fuel? The volume of the tank is going to be the volume of fuel. When that tank is full, it will occupy the volume of that tank. So they gave us the volume of the tank, that the tank is 60 liters. The capacity of the tank is 60 liters. So when the tank is full of fuel, the fuel will have a volume of 60 liters. So volume of fuel, V sub F, is equals to 60 liters. And 1 liter is 1000 cubic centimeter. So it's just for us to multiply this by 1000 to convert it to cubic centimeters. So we do that. 60 times 1000. This gives us 60,000 cubic centimeter. So next, we're going to calculate the mass. From density is equals to mass over volume. If you cross multiply, mass times density will give you is equals to mass. So you have that density times volume is equals to mass. This comes over multiply the density equals to mass. So you have density is in gram per cm3, we have 0.72 gram per cubic centimeter. Then the volume in cubic centimeter is 60,000 times 60,000. So if we multiply, let's multiply. 6 times 2 is 12. 6 times 7 is 42. Plus the 1 from the 12, 43. Okay. So we have 1, 2, 3, 4. 1, 2, 3, 4. Then the point, 2 decimal place. You count 2 decimal place from here. This is going to give you from here 1, 2. So this gives you 4, 3, 200 grams. This is 43,200 grams. So the mass of fuel is 43,200 grams. We convert this to kilogram by dividing by 1,000. If you divide this by 1,000, that's divided by 1,000 is like, you have 3 zeros in 1,000. So let's count decimal from outside. That is 1, 2, 3. So this is 43.2 kilogram. If you divide it by 1,000, you have 43.2 kilogram. So the mass of fuel is 43.2 kilogram. But this is not the final answer. This is just the mass of fuel. The question was the mass of the tank when full of fuel of relative density is what? An empty 60 liters petrol tank has a mass of 10 kg. Its mass when full of fuel of this density 0.2 is dash. So when full of fuel, we are going to calculate add the mass of the tank and the mass of the fuel. The mass of the tank is 10 kg. The mass of the fuel is 43.2 kg. So you add everything together. The mass, total mass now will be the mass of fuel, which is 10 kg, plus the mass of tank, which is 43.2 kg. So this gives us 53.2 kg. So our answer is D. So if you had already choose C, you would have been wrong. D is the correct option there. So the answer is 53.2 kilogram. That is the answer. So in our next lesson, we are going to do more calculations, and we will look at Archimedes' principle and upthrust. We look at upthrust, we look at Archimedes' principles. So I believe you actually enjoy this lesson today. So like I said, if you're not subscribed, make sure you hit the subscribe button and like the video, drop your comments, and in case you need a one-on-one lesson, you can always connect with me via my WhatsApp number there, which is +234 803829 5185. Thank you for joining us, and bye. Meet us in our next lesson. That will be lesson 5.